Hello, we are the team 기승전결 and we carried out the customizable mobile robot project. When we saw an automatic robot in a large logistics center, we thought that it is necessary for personal businessmen. But these robots are too expensive and difficult to modify its behavior. With rapidly growing nano-society, personal businesses are on the rise, such as store farm. Therefore, it needs to be cheaper and easier to use for personalization. So, for making robots more simpler, use line tracer and switch detection. Line tracer used Raspberry Pi and line trace sensor. It can simply determine the path of robot with a black tape. Switch detection use YOLO version 8. This is an image deep learning model using PyTorch and CNN techniques. It has advantage for fast object detection. And we detect these switches. It can determine our robot's behavior. It consists of a stop, U-turn, and action terminals A and B. Action switches have been replaced by flashing red and yellow LED. Basically, the robot runs following the line, and when camera detects switch, give an appropriate action. This makes easier to make behavior editing with the line and switches. And this is the system architecture. Basically, Raspberry Pi includes a camera and a line tracer module. And it uses socket communication to send real-time video to external computers. The computer recognizes the switch using image deep learning, and that returns the classes to the Raspberry Pi. The class's value determines the behavior of the robot. Socket communication is adopted because hardware performance is not good to run deep learning programs on Raspberry Pi. However, using this method is advantageous for smaller FPS. FPS represents frame per second. Also, we chose Raspberry Pi because it is cheap compared to the Jetson Nano Kit. This is advantageous for individual customers who are burdened with the price of the robot. As a result of deep learning, the F1 score curve for performance measurement is as follows. To elaborate on the advantages of the product, as mentioned above, it is easy to create and edit paths using tape. The switch can be easily manufactured using a pen. The switch thus made can be put directly into the circuit. Since the camera is mounted on the right side of the robot, the configuration of the switch can be adjusted differently depending on the direction of progress. This image is a reproduction of the above image. The left is the robot's movement and the right is camera's execution. This is the video when a more complex circuit is constructed. At first, it recognizes switch A and blinks red LED. Then it recognizes switch B and blinks yellow LED. After that, U-turn and stop follow. Our robot is easy to use and can customize various behaviors, so they can be used in various industries such as medical, logistics, welfare, and culture. This is the end of our presentation. Thank you for watching.